Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 7.1.3. The M&Ms for this is called Describing Association, and this is part one. And this is where, I've kind of talked about this already, but when you see a scatter plot, there are different ways that you can describe it. First of all, the direction that the flow of the points tends to go in can be described in this manner. If you remember, when we talked about lines that went in this direction, they always had a positive slope because as x increases, y increases, and you get a positive increase in both directions, which gives you a positive slope ratio. If the line went in this direction, that was a negative slope. So while x increased by a certain amount, y went down. And so that ratio ended up having a negative and a positive number in it, which gave you a negative slope ratio, okay? So remember growth rates. When your growth rate is a positive number, y is going to increase as x increases. When your growth rate is a negative number, y is going to go down as x increases. So think of that when you're thinking of a scatter plot that goes in this direction is considered a positive association or positive correlation. And then when it goes in this direction, it's a negative association or correlation. Hold on. All right, kind of dog barking. Let's get back to business. All right, and then when you've got a scatter plot where where would the line go? It's impossible to determine whether it's going up, whether it's steep going up, where it's flat going up. Is it going down? I mean, where would the line go? If it's so impossible to tell which direction the line would go, then that would be a situation where you've got no association, okay? So the x value has nothing to do with the y value. So think of the homework from the previous homework where you had that question where the number of pets that you own compared to the grades that you get in school. There's absolutely no connection between those at all. So that would be a no association kind of a scatter plot. And then you could have some scatter plots that go in a kind of a straight line, right? So this would be a linear one. And then you can get some that would go in a line that would be curving. So that would be nonlinear, right? Linear, nonlinear. Doesn't form a straight line. It's a curved line. And then this one, not as common, but this is what you call one that has clusters. So it kind of goes up, but then you got a cluster here and a cluster there. I don't see those very often, but you do see these, and you do see the linear ones quite a bit, okay? And so then the next part of describing association would be to describe whether it's a strong association or a weak one. So remember, the strong associations, all of these points really are close to your line of best fit. Whereas as you get more points that go away, it starts to get weaker and weaker and weaker until eventually it's so weak that you would just say that there's no association. All right, so what do we have here? It says for each scatter plot below, determine if there is an association, first of all, and then what is it? Label each graph as showing a positive, negative, or no association. And if there is an association, write a sentence describing it. Okay, so remember, for these scatter plots, you want to know what your independent and your dependent variables are. This is supposed to be affecting this. So what we're looking at here for A is, does the average number of hours watching TV per day affect your grade point average? And the expectation be the more time you spend watching TV, the less time you're spending on your schooling. Okay? Now this is sort of old school. It used to be, we used to have a lot of homework to do after school, whereas most of the time we're building in most of that time during class time. So by the time you go home, you got, ride your bikes, watch TV, do whatever you want to do, play with your phone or whatever. But that's definitely a negative association, right? Because you can kind of see it. It looks like it might be a moderate, not really weak, but it's moderate. It's not a strong association. You certainly have some people that could watch. I would have to imagine that there's an outlier, someone who watches a lot of TV and also gets really, really good grades. And then you got that poor soul that never gets to watch any TV, but they also struggle in school. It does happen. All right, and then your age and the number of gray hairs on your head. All you have to do is look at my head to see that the older you get, the more gray hairs you get. So there's absolutely a positive association to that. The older that you get, the more gray hairs that you get. And then the length of your hair and your shoe size has nothing to do with each other. You can cut your hair short and have monstrous feet, or you could have super long hair and have really big feet. It doesn't make any difference. There's no association. All right, draw a straight line that models the trend of the data on this graph. Okay, make a graph of Team 2's data from problem 725. What was problem 725? Oh, oh, that's right. This is the one where we were looking to see, we were controlling the different variables. Actually, you know what? Hold on for a second. Okay, had to refresh my memory. This was about the plants, and you were to plant the seed, and what we were doing was trying to find out the different variables, how they affected the growth of the plant, okay? And so for this particular problem, here would be the data, right? And so you can clearly see there's a negative association to that data, and it's a pretty strong association too, right? Those points come really, really close to the line of best fit. And so it says you use your line of best fit to predict the height of the plant when the seed is planted 14 centimeters deep. So this would be where 14 centimeters deep is. And so we would go to, that would be 12, 13, 14, 15. So that's 14 centimeters. So what would we expect that to be? We would expect it to be probably around 7, between 7 and 7.5, somewhere in that range. So what is the y-intercept represented in this situation? The y-intercept appears to be right around where the 30 centimeter mark would be. And so if a plant is seeded at the surface, it will grow to about 30 centimeters in 3 weeks. That's really the interpretation of that, right? This is the height of the plant. And is that what it's saying? Is that depth of the seed? Oh, yes. So the depth, it was the depth of the seed, it was right at the surface. And so that's what we would expect it to be after 3 weeks. I guess I just said that, didn't I? I was so confused on that problem. All right, moving on to number 31. It says, during a given week, the museum had attendance as shown at the table at the right. So day 1 had this many people, day 2 had this many people. So some days had more, some days had less. So it looks like the highest population was 940 people, but attendance, not population, and the lowest attendance was 400 on day 4. So numerically summarize the center and spread of attendance by finding the median and the interquartile range. Okay, so what this means is, if we're finding an interquartile range in the median, we're going to have to do a box plot, because these are all associated with box plots. So take these numbers and put them in order from least to greatest. The least, I'm going to call this guy the minimum, and this guy is going to be the maximum, right? But we've got to put them in order. So what is the order here? Which one is, I'm going to rank them right now. So this is 1, then 2, and then 3, and the 4th day would be the median, which would be this guy right there. So that's going to be your median. And on the 5th day, it would be this guy's. That's the ranks 5th, then 6th, then 7th. Okay, so the interquartile range. Oh, I'm doing this. I guess, yeah, I'm going to have to do the work. I'll do it. Oh, I didn't want to do it. Okay, so let's put these in order. So you got your 400. You've got your, what comes number 2, the 593. Then what comes after that, you've got your 680. Then what comes after that, you've got your 731. And we said this was the median, right? It's right there. That's your median. And then the 5th one would be 861. And then your 6th one is 870. And then your maximum is 940. For a total of 1, 2, 3, 4, 5, 6, 7. Okay, so we got your minimum, your maximum, and your median. Now to find the interquartile range, You got to take everything below the median, and you've got two numbers that are below the median, right? Oh, no, everything below the median. Hold on for a second. That would be everything here to here. So your lower quartile or your first quartile is going to be that number. And here's everything above it. So this is going to be your third quartile. So your minimum, your first quartile, your median, your upper quartile, and your maximum are all listed there. So the interquartile range is going to go between the 593 and the 870. So take 870 minus that, and that's 277. It's a lot of work. I can understand you not wanting to do this, but you can do it. It's not that hard. Why do I have that there? All right. So then the museum management needs to tell the staff members their work schedules a week in advance. The museum wants to have approximately one staff member for every 150 visitors. How many staff members would be scheduled to work? All right. So if the median is about 731, if you were to take that and round it up to 750 and then divide that by 150, what does that end up being really close to? Isn't that like 5? 750 divided by 5? Yeah, that's what it is. So you could be justified in saying 5 employees at the minimum because that's the median, but that's the median. You've got some days, like half of the days are more than that. So I'm suggesting to do like 6 employees, because that would cover between 750 and 800, somewhere around there, or between 7 and 900, somewhere in that range. You're going to be safe. And sure, you'll have a couple of days where you'll have too many people working, but 5 or 6 seem like a good number there. And then why is the scatter plot not appropriate for this data? Well, because we don't have really an association between 2 different variables. What we've got here is we're looking for a distribution of data. We've got this data right there, and we want to see how it's distributed between the days. All right, last 2 problems. Solving rational number operations where you're multiplying positive and negative rational numbers together. In this case, I would probably, since I don't want to change the 2/3 to a decimal number, I would change this to a fraction. So this becomes 2/3 times 8/10, which then gets simplified from 16/30 to 8/15. Here, you can cancel out those guys and leave you with 4/7. Here, you end up with -20/42, which becomes -10/21. And in this case, we would want to rewrite this as -4/5 times -4/3, and that's how you get positive 16/15, because a negative times a negative ends up giving you a positive answer. And then solving these equations. Check your solution. These are not fun at all. At all. I'm going to tell you that right now. But we can solve these problems by doing fraction busters and making them a little bit easier to solve. But remember, it's kind of like going to the gym and jumping on the Stairmaster for 45 minutes to an hour. You're not going anywhere, but your exercise is making you stronger. So that's what is happening here. The exercise of working through this process makes you a stronger algebra student. So I'm going to choose a denominator of 4 would be my common denominator. So I'm going to multiply every single one of these terms. This one, this one. Oh, I really want to, okay, hold on for a second. I'm going to do distributive property first and make this 3x over 4 minus 8 minus 4x is equal to -1/2 of x plus 1/4. All right, so now let's multiply everything here times 4. This one times 4, this times 4, this times 4, this times 4, and this times 4. Every single individual term has to be multiplied times 4. So the 4 cancels out with a 4 there, leaving you with -3x. 4 times a -8 is -32. 4 times a -4 is -16, so that becomes -16x. 4, if I cancel out the 4 and the 2, that's going to become a 2, so it becomes -2x. And then the 4 cancels out with the 4, making that +1. Combine like terms, you're going to get negative 19x minus 32 is going to be equal to negative 2x plus 1. And now I will add 19 to each side, 19x's to each side, because this is going to cancel out, right? And then I'm going to subtract 1 from each side, so it becomes plus a negative 1. Hold on for a second. Which gives me negative 33 is now equal to 17x. Oh, where did I make my mistake? Hold on, I got to find it. That's got to be the correct, or that is the correct answer. Let me check. Found it. Well, that's not a negative 3x, it's a positive 3x. I don't know what's going on there. So change that to positive 3x. So when you combine with like terms, let me go ahead and get rid of that, get rid of this, and get rid of that. This would be negative 13x. So when you add 13x's to this side, you would then add 13x's to this side, and that's going to become 11x's. So now when you divide by 11, you get x is equal to negative 3. So I hope I was able to properly illustrate for you, excuse me, the importance of showing your work. You see how I made a mistake, but I didn't have to erase everything and start over. All I had to do was find where the mistake was and just fix those two parts, right? I fixed this part, this part, this part, and this part, instead of having to redo the entire thing. So be nice and neat, showing your work, and it makes it easier if you got to make corrections, if you got to fix a mistake that you made. Okay, let's go over. Do I want to do this one too? I think I should probably do this one, even though it's taken forever to do this. I believe I want 15 to be my my multiplier. So I'm going to multiply every one of these. Let me just write this out. 5x over 3 plus 2 over 5 minus 1 over 3x plus 1 equals 0. And if I choose to multiply everything times 15, I'm going to do it this way now. I'm going to take 3 and 5. No, that's sloppy. Do it better. 5 and 3. And I'm going to do that here. I'm going to multiply it times the 2/5. I'm going to multiply it times the 1/3. Multiply it times the 1. And I'm going to multiply it times the 0. So let's do this in red so it all shows up nicely. So here the 5, no, it doesn't. The 3 cancels out with the 3, leaving you with 5 times negative 5x is negative 25x. Here the 5 cancels out with the 5, leaving you with 2 times 3, which is 6. Here the 3 cancels out with the 3, so it's going to be 5 times 1 times x is minus 5x. And then 15 times 1 is 15. And that's going to stay as a 0 because 0 times anything is 0. So now when you combine like terms, that's going to be negative 30x. And that's going to be positive 21 is equal to 0. So now I'm going to move my x's to this side by adding 30x's to each side. So it's going to become 21 is equal to 30x, right? Because whatever you add to one side of the equation, add the same thing to the other side. So your term turns into its opposite when you move it to the other side. So they cancel. And now we divide both sides by 30. And 21 over 30 is the same as 7 over 10. So the answer to this is 7/10 for x. And you really should check it. I'm certain nobody did because I don't want to do it either. That's a horrible, both of them. Well, actually, that's not a bad check here. That wouldn't be bad to check that. This is a horrible check. I wouldn't want to do it. All right, last one. So the figures to the right are similar. So they're two kinds, right? Describe the sequence of transformations that will exhibit the similarity between them. Okay, so this is a little bit bigger than that one, so it's going to require a dilation. So what you would have to do is rotate it 90 degrees to the right, or clockwise. Then you probably, I would dilate it first, according to some scale factor, And then once I got it oriented and the right size, then I would slide it over, do the translation. So it could be in any of these orders, but I'd probably actually do 1, 2, and then the translation would be number 3. All right, and that ends our homework. So let's, yeah, that's way longer than I wanted it to. That wasn't a fun homework. All right, let's move on to the next activity. Bye.
Hey, feeling good, like I should.